All righty, it is, if you can believe that, February 6th, the very first day of NHA on a Thursday in the month of February in the year 2025. And so we did have good old Puxaquanny Phil, the groundhog in Puxaquanny, Pennsylvania, saw his shadow, which apparently means we have a longer winter in store for us. And case in point, it's raining outside as we speak, and it's at least raining where I am. And so, anyway, let's go ahead and get to lessons 69 and 70. And we'll be doing some pretty important stuff here. The second part, I'm going to teach you something you haven't learned yet. And so hopefully this will be a help to you. The first two questions that we're going to do are not as hard, but 3, 4, and even 5 are going to be difficulter, something you've not learned. And I'm going to show you several different ways to do these types of problems. Very important stuff moving forward here today. And then I think that stuff on the next lesson is kind of hard too. It's totally different than what we're learning today. So today's an important day in all things Algebra 1. So let me go to the whiteboard and see if we can make a little bit of sense on these things. And okay, so number 1 is not too terribly difficult. Neither is number 2. I said, do that. Sorry about that. Put the box right where I'm writing. 3x plus 5. Okay, so what we have to do here is this. We have to use the distributive property in order to multiply these two things. So this 3x that's outside the parenthesis is basically saying I must multiply everything inside the parenthesis by that which is by outside. So I have to multiply this here and here, both spots. So 3x times x is 3x squared. And we've kind of done these things already, so this is nothing too new for us. I'm not sure we've done it exactly like this, but it's something you've kind of done. Who's not hearing me? Oh, Amy, you're okay now, right? Oh, you didn't hear me earlier. All right, good. Then 3x times 5. Again, you put the plus that's here. So you go this times this 3x times the x is 3x squared. The 3x times the 5 is 15x. So our answer is, and you can't simplify this because remember we just learned you can't add or subtract unless you have the exact variable with the exact exponent. And when you do, you just simply add the coefficients together. But since this is squared and this is to the 1, an understood 1 power there, you don't have to express it, but there's understood. They're not the same. This is the simplest form. This won't show there, so I'm going to erase that, but it is to the 1 power. And so the answer to this will be letter C. All right. So that's that one. That's something we've kind of already done. We'll do something similar here with this x minus 2. And again, the reason you don't subtract this together to begin with, you say, well, doesn't parentheses come before multiplication? Yes, it does, but you cannot subtract a variable and a whole number. Or vice versa, a whole number from a variable, or add. Okay, so we have to go x times x is x squared. X times the negative 2 is minus 2x. X squared minus 2x is our final answer. That's letter A. All right. Those ones right there, though, I went a little fast because the next ones we're going to take some time doing because they're going to be nice and difficult for us. So on 1 and 2, thumbs up if you get it. Thumbs down if I went too fast. You want me to slow down a bit. On the count of 3, 1, 2, 3, go. All right. Okay, so now we're going to do something we've never done before. And it's important for us to do this, okay? So now I have this. I have x plus 1 multiplied by x plus 2. Okay, now there's 3 different ways to do this problem. Okay, each of them have a benefit. Some of them are easier, but you can't do it to other problems later, so you have to learn all 3 ways. Okay, the first way I'm going to teach you is called the FOIL method. Has anybody here ever heard the FOIL method before? Put a thumbs up if you have. Okay. One person? Okay. The first method is called a FOIL method. So let me erase the FOIL, the letters here. Let me give you what they mean first, and then we'll erase them because I need room here. F stands for first. O stands for outer. I stands for inner. L stands for last. First, outer, inner, last. It's called the FOIL method. So watch carefully how I do this. Let me erase these letters and I'll show you what I mean. So the first is these two here in both sets of parentheses. X times X is X squared. Okay, that's the first. The outer would be this. X times 2x with a plus there. Now, once you start getting into minuses, it's really going to change as well. So you got to be extra special paying attention to what you're doing here. They're both positive, so it does make it a little bit easier. Let me see if there's any that have. None of them today are going to have one positive, one negative. They're either going to both be negative or both be positive. A little bit easier for us. It's going to get harder in the next few weeks or few lessons. Okay. So the first is the x times the x is x squared. The outer is x times 2 is plus 2x. Now we go inner. 1 times x is just plus x. Then you go last. And it's 1 times 2 is plus 2. Okay? So now I've gone FOIL first, outer, inner, last. And all I do is combine these like terms now. So I can't add the x to anything, so it's x squared. 2x plus x is 3x, then plus 2. Okay? So this is our simplest form. This is our answer right here. We multiplied x plus 1 in a parenthesis times x plus 2 in a parenthesis, and our final answer is letter D, x squared plus 3x plus 2. All right? On that problem and that problem alone, with what I've explained, did you thumbs up, get it? Pointer finger in the middle? Thumbs down, kind of completely lost. Count of 3. Here we go. 1, 2, 3, go. Okay, I see a thumbs down. All right, let me show you the other way it works and see if you can. This is what that's called the FOIL method. The second way you can do this kind of problem is this. You stack it. And to me, this is my preferred method, and this is the way I still do it. I do not personally use the FOIL method. I teach it to you because on some of the easier ones, it really makes it quicker, like that one right there. But the stacking method kind of is universal, so you can do it for all these things. It's my preferred. I'll do the exact same problem. Let me rewrite that, sir. I'm going to go to the order, and we know order doesn't matter in multiplication, but I'm going to do it in the order they did it just to not lend yourself to any confusion. So I'm going to take these two. I don't have to put the parenthesis now. I can if I want to. But now what I'm going to do is this. I'm going to take the exact thing I learned in the 3rd and 4th grade when I multiplied. Let's say in the 4th grade, I multiplied 43 plus 27. Okay? And what you did is this. Watch how you did this in the 4th grade. You multiplied this 7 times 3, and you got 21. Then you go 7 times 4 is 28, plus 2 is 30. Then, because now you're multiplying for the 10 spot, you have to either leave a blank here or put a 0. Either way, doesn't matter. We'll put a 0 because that's how they first taught you. 2 times 3 is 6. 2 times 4 is 8. Once you get this far, you just add up these columns, and you get 1161. 43 times 27 is 1161. So you know how to do that. You learned that in the 3rd and 4th grade. I'm going to use that same exact method, though, and I'm going to multiply these two terms together. And there's a couple things you'll have to be aware of that are addition to this. But watch. 2 times 1 is 2. So I multiply this by this, just like I did in my little illustration here. I should have left that so I show you. Now I'm going to go 2 times x is 2x. Okay. Now I'm going to put a 0 here. I don't have to put that 0, but I will. Now I'm going to go, because I'm now from the 10 spot, x times 1 is x. Wish this thing was not in the way. Is there a little box in the way for you right here or no? Right where the x plus 1 is? Or do you see all that? It might just be for me. It says how many people are watching this. Okay. Kind of in my way, but I don't care. As long as you can see this. Then you go x times x is x squared. Now, all we have to do is add, just like we did in our multiplication problem. The x squared just comes down. 2x plus x is 3x. 0 plus 2 is plus 2. We get the same exact answer, which is letter D. X squared plus 3x plus 2. Okay? That is my preferred way to do this. I stack these. And by the way, Dayton, these are binomials now, just so you know, because a binomial simply means you have an x squared and an x. That's what would make it a bi. Bi meaning two, nomial, so binomials, polynomials, trinomials, we'll get to all those things. Okay, so let me show you one more way to do this, okay? It's just a box. And you need the box to have every spot that you'll have. So you'll have the x plus 1 on the top. You got to keep your positives and negatives right here too. Right now it's all positive, so it makes it a little bit easier. But when you get into negatives, you have to remember your rules of positive and negative numbers. Okay? So now all we do is this. X times x is x squared. So I multiply this by this and put it in this box. Now I multiply this by this and put it in this box. X times 2 is 2x. This x times this 1 is x. And then the 1 times the 2 is 2. Then we just cross add. And when you get bigger boxes, you'll see how if you get a trinomial multiplied by a trinomial, you'll see why the box method might help you. But here we only have one thing to add. So the x doesn't add, x squared doesn't add to anything. The 2x and the x just looks like this, and then the plus 2. There's your, we've kind of done the same thing on all three of these, just different ways to do it, okay? This is my least preferred method. My first method would be the stacking method. Then if it works, the FOIL method. And then this method would be my third and final way to do these. You figure out, again, you'll kind of need to know how to do all three as you get into more difficult problems. But let's go on to the next problem. All right, here we go. Let's go to x minus 1. I'm sorry, x minus 5, x minus 1. And again, like I said earlier, when one's a positive and one's a negative, it does force you to be super extra careful. Okay. If they're both positive, it's easy, easy, easy. If they're both negative, you got to just be mindful of the negative. If one's positive and one's negative, that's where you really have to be super careful. Okay, let's try the FOIL method first. X times x is x squared. That's the first units. Outer. X times 1 is x. So x times a negative 1 is negative x, right? So I have to make sure I put the negative x. Okay? Now I have a negative 5 times x is negative 5x. And now watch though. That was the first, the outer, the inner, which is 5 and x, and now the last, which is negative 5 times a negative 1. Now watch, negative 5 times a negative 1 is a positive 5. I combine these like terms. My final answer is x squared minus 6x plus 5. That's my final answer. And that is, they put this in a parenthesis there. They have plus and negative. That's kind of dumb that they do that. But the answer is letter B. Okay. So again, let me just randomly do one, let you try it. Okay. Because I want to do the next one with you, but I want you to try one. So I'm going to just make up a number. I'm going to go x minus 4, x minus 3. I want you to multiply these two terms here. And on the answer, it's going to be hard for you to do that. So write out the answer like x, and you probably can't do the exponent, I wouldn't imagine. Maybe you can. I don't know if you can or not when you chat me over the answer. Why don't you just try it? We won't have you chat me over the answer. Just try it, and then I'll do it for you. When you get it done and you think you have the correct answer, I'm not going to ask you out loud. Or I'm not going to put you on the spot. But when you think you're done and you okay, there's an answer from uh, you got one thing that you did wrong there, Samuel. Look at it again. And by the way, that is the correct, I think, thing for squared. So Samuel sent me over this little symbol here. I'll show it to everybody. It's this for the squared, he put like that. So he put X, and that's actually the way to do it. And then when you want type it in programming, that's what you do. So when you do this X and this postscript too. So yeah, Milana, you do the same thing. You got the correct answer, by the way, as well. Milana. So good. All right. So you guys are getting this. All right. So you go X times X is X squared. X, the first outer, minus 3x minus 4x, negative 4 times negative 3, positive 12. You'll have x squared minus 7x plus 12 will be the right answer. Let's stack it and show you how it would stack. X minus 3, x minus 4. Negative 3, negative 4 times a negative 3 is a positive 12. Negative 4 times x is negative 4x. X times a negative 3 is negative 3x. X times x is x squared. X squared, add these together, minus 7x, or plus a negative 7x, you could put, plus 12. Okay. All right, so that's good. Let's go ahead and go to number 5. Now, number 5, we're going to use the stacking method only because the FOIL, a little bit harder for this because you have the third spot. So anytime we multiply numbers, if you had 794, let's say you had 13 times 794, you could either go 794 times 13 because order doesn't matter, or 794 times 13. Now, in this particular one, it'd be easier to put the 13 on the bottom because it's only 2 spots and it's easier to multiply 3, and 1, right? So that makes a lot of sense. Order doesn't matter. But if you have something like this, like 701 times 97, maybe it'd be easier to go 701 times 97 because the zeros are going to cancel out and there's a 1 there. That's easy to multiply. So order doesn't matter. You choose the way you do it. You'll get the same answer if you follow the mathematical rules. But what I'm going to do is this. I'm going to put the x squared, this is for number 5, plus x plus 5 on the top, and then do the x plus 4 on the bottom. X, okay? So now what happens when I do this? I'm going to multiply this by these 3 spots, then do the same thing here, and you'll see what happens when I do that. 4 times 5 is 20. 4 times x is 4x. 4 times x squared is 4x squared. Okay, perfect. Now I'm going to do this. X times 5 is 5x. Remember, you have to have like terms to add and subtract. Look, it automatically lines them up for me. The 4x and the x, I can add those together. Now I have the x times x is just going to be x squared. And then I have x times x to the third is going to be x to the, I'm sorry, x times x squared is x to the third. So now I'm just going to add these together. X to the third, 4 plus 1 is 5. 4 plus 5 is 9, plus 20. Again, easy because it's all addition. You really have to be careful if you have 1 plus, 1 negative, wherever they are. So there's no, all the like terms are combined. So the answer is going to be letter E. All right. On the count of 3, thumbs up, pointer in the middle, thumbs down on this particular problem right here, number 5. 1, 2, 3, go. Good. Anybody lost completely? All right. Number and there is when you're actually reducing things, there's something that I think they want you to see here on number 6. And you're going to go back and forth between either multiplying these out or factoring them, because the opposite of multiplying is factoring, right? And I think the reason they want you to see this 1 here is because there's always a place value that you have to hold, especially when you're going backwards. So we just go 6x times x is 6x squared. 6x times 1 is just plus 6x. Your answer here is letter D for number 6. And again, you'll see this when you go reverse this place value. You'll see why it matters when you have a 1 here. When you're multiplying, you just see it pretty easily. When you go backwards, that's when it's, yeah. On number 7, it's saying this: select the expression for the area of a square with the sides of x minus 4. So if you had a square and it was x minus 4 on one side, all you would do is length times width. So it's x minus 4, x minus 4. Negative 4 times negative 4 is positive 16. Negative 4 times negative times x is negative 4x. X times negative 4 is negative 4x. X times x is x squared. X squared minus 4x plus 16 would be the answer. It'd be letter C. So all you did was take x minus 4, and since it's a square, and a square is length times width, this times itself. It could look like this: x minus 4 squared. And it's going to get you that answer. All right, for letter C. Why don't you try number 8? All you're going to do is be multiplying those 2 expressions together. Get me an answer. Send me over your answer.
Why did you not add the minus 4x and minus 4x to get negative 8x?
Say that again.
Why did you not add the minus 4x and minus 4x to get negative
I did. I
8x?
just didn't. I didn't finish it, but maybe I should have. Let me do it again since you didn't see it, or maybe I didn't finish. Negative 4 times negative 4 is positive 16. Negative 4 times x is negative 4x. X times the negative 4 is negative 4x. X times x is x squared. Answer, x squared minus 8x plus 16. Letter C. All right. For number 8, it looks like it's a rectangle, and it looks like this. X plus 2, not to scale, and x minus 5. Maybe it is the scale. I don't know. So you have to multiply. Here's a plus and a negative. Be very, very careful. We haven't even done one of these yet. Just multiply this times this and get an answer. Let me know if it's A, B, C, D, or E. Gotta sneeze again, guys. Is anybody raise your hand if you're completely lost and you're waiting for me to do it? I learned this for you. If you do these symbols, it gives you a background. That's pretty cool. I don't know if I have that on recording yet, but that is pretty cool. Yeah, we're getting into some harder stuff. Length times width, x plus 2, x minus 5, negative 10, negative 5x, 2x, x squared. I'm going to have x squared minus 3x minus 10, or x squared plus negative 3x plus a negative 10. Either of those would be the right answer. So that would be letter B. All righty. Letter B is the answer for number 8. What we think so far? That fun? Of course it is, Mr. Soto. All right. Turn your page. Not fun, Amy? All right, let me show you something here. I'm going to show you why this is why it is. I have z to the 9th. Yeah, it is getting a little bit hard. Over z to the 4th. I could express z to the 9th, and this is going to be something new for you also, but it's not too terribly difficult. There's just one thing that you need to remember, okay? So this next lesson might seem a tad hard, but it's really not. But you really have to learn, okay? Let me show you how this would look if I factored this out. Z to the 9th is the same as z, 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 1, 2, 3, 4, 5, 6, 7, 8, 9. Z to the 4th would be z, 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 z. Now watch what happens here, okay? These will cancel each other out, and you have z to the 5th over 1 left over, which is just z to the 5th. So your answer here for number 1 is z to the 5th. Okay, that kind of makes sense. Thumbs up. Okay. But watch this. This z and this z are exactly the same. So meaning the bases are the same. When you see that, you just go 9 minus 4, numerator minus the denominator of exponents. 9 minus 4 is 5, z to the 5, a little bit easier. Okay? But here, and okay, so that makes sense? Yes? Okay, now listen very carefully to what I'm about to say to you because this is very important. In exponents, you can't mathematically have a negative exponent. Okay? So let me show you a few different things. Let me show you the next one and how it would work with the same exact thing I just showed you. Okay? I'll show you both ways. X to the 1 over x to the 6. I'll rewrite this as x over 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. Oops. But you have to place that place value of 1 because it's a numerator. Okay? X is now to the 5th. Our answer would be 1 over x to the 5th. Okay? So that's the correct answer. But you may say, Mr. Soto, I don't want to do all these x's like that, especially when we get 60 or 70 x's or whatever they are later on if it gets much, much, much more complicated. And you might ask yourself, well, can I do it the way you did it earlier on the other one with the z's? You can, but you have to remember a rule of math, okay? And that's this. Let me show you again. I'll back up. This is the correct answer, by the way. And by the way, on the first one, like example, 2 over 1 as a fraction can also be expressed as 2. But 1 over 2 as a fraction, you have to leave that as a numerator, right? So any number can be expressed over 1. So the very first one we did was z to the 5th over 1, which is just z to the 5th. Here, because you have this 1 here, it has to stay there because it's a numerator, okay? You learn that, again, I told you before, you take these things you learned in math when you were, you know, um, in the third, fourth, fifth grade. You're just doing them again, just harder. So let's do this. Let's go x1 minus 6 because we just took this number here and we subtracted it there. So now you have x to the negative 5th. Okay. Anytime you have a numerator with x to the negative power, what you have to do is just reciprocate it and go x to the 5th power, which is the same answer we just got. You cannot have a negative exponent. So you just write it with the exponent, the same absolute value of it, which is negative 5, it's 5, but you write it in the denominator. Okay. So I told you, this isn't hard. You just have to learn these kind of 2 or 3 little rules. I mean, all we've done so far is elementary math. Then we went into pre-algebra math with a negative number here. And then we just invert it because that's what we do when we have exponents. Okay? So again, the answer is the same. Let's keep on going. Now, this is another thing you need to know in math. Y to the 0 is our answer, except you always express any number with an exponent of 0, you express it as a value of 1. And someday when I have more time, I'll show you that. Any number, any value, any variable to the exponent of 0 is 1, not 0, and not itself. For example, And I can just show you this really quick. Let me show you something else and I'll get back to that problem. Take the number 2. Okay, I'll go backwards. 2 to the third power is the same as 2 times 2 times 2, which is the same as 8. 2 to the second power is the same as 2 times 2, which is 4. 2 to the power of 1 is just 2 one time, which is 2. 2 to the 0 power is going to be the value of just 1 because any number to the 0 power is not 0. The reason being is when you multiply by 0, you get 0, and you can't do that. It would negate all these complicated mathematical problems. So any number, including 735 to the 0 power, is just 1. You might see a problem like that on SAT standardized testing. Don't put 0, don't put 735, put 1. Anything to the 0 power is equal to 1, including a large number, including a variable. It's always equal to 1. Okay? So number 3 is y over 7. I'm sorry, y to the 7th power over y to the 7th power. You could do this. And this kind of illustrates very quickly. There's a little bit 1, 2, 3, 4, 5, 6, 7. There's a more elaborate 1, 2, 3, 4, 5, 6, 7 rationale as to why. Every single one of these y's has an understood 1 in front of it, right? Let's cancel them out. There's an understood 1 in front of all these values. 1 times 1 times 1 times 1 times 1 times 1 times 1 is 1. 1 times 1 times 1 times 1 times 1 times 1 times 1 is 1. 1 over 1 is equal to 1. So watch, right? That's our answer. Y to the 7th over y to the 7th. 7 minus 7 is 0, so y to the 0 is equal to 1. All right? Something you just need to learn. And again, I'll explain to you a little bit more in detail why this applies in maybe complicated math. But for right now, I just kind of showed it to you quickly and briefly. Okay? So here, again, you can do this for number 4. You can say x to the 7th over x to the 10th. And you can say x, 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 1, 2, 3, 4, 5, 6, 7. X, 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 x. 10 of those, I hope. We just cross them out. 1, 2, 3, 4, 5, 6, 7. I'm sorry, 6, 7. We have a 1 left over there. That's our numerator 1. We have 1, 2, 3 left over, x to the 3rd. That's our answer for number 4. 1 over x to the 3rd. You could do it the subtraction way as well by doing this. Stop. All right. Answer number 4. So we have 4x minus 10, same base numbers. I can do that. And by the way, the bases have to be the same in order to do this, just so you know. I think I said that earlier, but I'll. So we have now x to the negative 3. Anytime you have a negative exponent, you just do the reciprocal of it with a positive exponent. There's your answer. All right. Number 5 should be easy. Why don't you try it? Number 5. I did the harder ones for you. You can do the easier ones. Right. You can do that in this one, yes. And because you're going to have a positive value, you'll just have a letter and a number. Yes, you can do that. Absolutely, Amy. for Amy, the question you text me. Yep, good. Yeah. Yeah. So again, if this value is positive, you leave it the same. If this value is negative, meaning the exponent value, then you just reciprocate it over 1 with its absolute value counterpart. Meaning if it was -3, I won't say -3. Let's say you did one that was like this, you know, r to the 2, r to the 8. Well, you go r2 minus 8, r -6. So the answer would be 1 over r to the +6. I made those numbers up. But since this one here is already positive, it's just z to the 3rd power. Okay, let's do numbers 6, 7, 8, 9, and 10 together. Number 6, we just showed you that that is equal to 1, yes. So yes, y over 9 and y over 9 and 1, those are equivalent. Okay. 0 and z to the 0, no. Anything to the 0 is 1, not 0, and I kind of showed you why. Okay. On number 8, let me show you number 8. We have y to the -2 and 1 over y to the 2. Well, I know I can't have a negative exponent, so I'm just going to reciprocate it over 1 y and use the absolute value there of 2. And look, they're exactly the same. So the answer to number 8 would be yes, these are equivalent. Okay. This here is, don't let this confuse you, x to the 9 minus 5 and x to the 4. Because of this parenthesis here, look at very carefully. This is number 9. I kind of sped through 6, 7, and 8 because I felt like they were relatively review and easy. Here, though, watch. Don't let this little parenthesis here confuse you. It's not this. There's a parenthesis here, so you're multiplying. And that would be x to the 9 -5 number of times. Okay, so the answer, to simplify this, you'd actually do this. It would be x to the -45th, which is 1 over x to the 45th, and x to the 4th. This would simplify to this, so this is not equal to this. It makes sense? Count of 3. Thumbs up, thumbs middle, thumbs down on number 9. 1, 2, 3, go. I tell you what, we're going very fast, learning a lot today. Make sure you're doing your teaching textbooks online curriculum because, yeah. Okay, I see a couple pointy fingers. Okay, let's try number 10 then. We'll simplify the left and see if it's the same as the right. X over 6, x over x over 3, and x over 3. I mean, x to the 3rd power. So this is just 6 minus 3. So it's 6 minus 3 is 3 over 1, which is just that, is equal to, so yes, x to the 3rd. Simplify both sides, see if they're the same. If they are, you put yes. If they're not, you put no, or equivalent or not equal or something of that nature. All right. Let's do this. Let's go ahead and call that a day. We'll finish about 3 minutes early. Again, make sure that you're doing your teaching textbooks curriculum, because the best way for you to do these problems is to not let me do them all for you. It's for you to do them on your own. So make sure you're doing that, okay? That being said, anybody have any last minute questions? Okay, that's not, I mean, 3 out of 5, you got to work on those a little bit. So that's okay though. Got to keep on going, keep on going, keep on learning. Again, some of these things are light bulbs. Once it clicks, it clicks. Some of this math stuff. And sometimes it's like you struggle, you struggle, you struggle, then boom. So nine again. Yes, I'll show you nine again since you're asking. So number nine looks like this. They're asking you if x minus 9 to the fifth power. No, I'm sorry, I did that backwards. Hold on. X to the 9 to the fifth power, negative fifth power, and x to the fourth is the same. Okay. So I have to simplify this problem right here to see if it's the same as this. Okay. So, but we learned this a week ago that when you have, or maybe we did this Tuesday, x to the ninth is like this, x to the ninth 5 times, negative 5 times. Okay. Which is the same. I'm not going to write it all out. And I showed you why these things are. I like to just give you kind of illustrations, but this is a little too big to do it. So anytime you have this x to the ninth power to the negative fifth power, in order to solve this, what you're simply doing is multiplying the negative 5 times the 9. So you have x to the negative 45th power. Okay? We already see it's not going to be equal to this, but I'm going to simplify it all the way. Yeah, so it'd be x to the negative 45th power. I'm going to simplify it all the way just so you can see why not. But you can't have a negative exponent. So when you do, you write it like this. Oops. Sorry, hold on 1 second. Got ahead of myself. So this whole thing right here would simplify to this. And as you can see, this here and this here are not the same. So the answer to number 9 would be no. Now let me just show you one thing that they could have done, and it would have looked similar, but it wouldn't, it would have been the same. They could have done this. X over 9, X over 5, and X 4. If it looked like it doesn't, I'll call this number 11 because I just took some of the what number 9 was and just kind of made a problem similar. Then what you would do is this. You would re-express this as x to the 9 minus 5. Now notice this looks very similar to number 9 with one exception. There's a parenthesis there on number 9. There's not a parenthesis here. So because of that, this would then be x to the fourth and x to the fourth. And you would conclude that this would go to that, would go to that, which is the same as that. But because it has a parenthesis here in the actual number 9, that's why they're not the same. That parenthesis matters. And we know in math where you put a parenthesis matters because a parenthesis implies the operation of multiplication. Okay? So all that to say, the answer to number 9 is no. All right, that'll do it for time. Getting a little tougher, which is fun. We're glad it is. I will see you on Tuesday.